Batu. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Alhamdulillah, today I'm going to present about road inspection at Federal Road in Batu Pahat using unmanned vehicle UAV. For the introductions, in the industry, a lot of methods are used in order to evaluate road inspection, either the traditional method or conventional method. The traditional method has many limitations and can cause harm for workers involved in the road inspection due to high traffic, especially in highway areas. Therefore, using UAV and mapping software to collect the data needed for road inspection will drastically reduce the waste of time and resource. The use of UAV technology for road inspection will increase the safety of inspection officer. One aerial photography is complete, investigating authorities can review the data at the office. This will be reducing the time it takes to stop traffic and increase the safety other traffic user and also control officer. This is objective of the studies. First, to determine and identify the type of road distress, and second, to identify and determine the pavement condition index PCI of the road using UAV technology. So for the literature review, we start with road pavement distress. Actually, road pavement distress related with the surface failure. What is the surface failure? Surface failure is any indication of poor or unfavorable pavement performance or sign of impending failure or any unsatisfactory performance of pavement short of failure. So actually road pavement distress occur because of the many factors. So we have a couple of the factors that affecting the performance of road, such as traffic volume, moisture, subgrade, construction quality, and also maintenance activities. For example, moisture can enter the pavement structure through crack and hole in the surface, literally through the subgrade, and from the underlying water table through capillary action. So that's why we need to method to investigate the performance of road surface. So pavement condition index is one of the method that we can use to inspect the road performance. So the PCI is important indicator to monitor the condition of the road surface and also to identify the maintenance and rehabilitation need for road surface. So, and UAV or unmanned vehicle system, also known as a UAS, what we call the unmanned aircraft system, and commonly known as a drone. So the UAV is the new technology that we can use to road inspection because of the advantage of the UAV can fly with safe and cheaper cost. Okay, for the methodology, start with issue identification, literature review, site determination, collection of data, analysis and process the data, discussion and conclusion, and then finish. For the collection of data, which is to mapping the study area by using DJI Pattern 4 Pro version 2. First, we need to find a suitable place which is far away from any cable, at least 3 meter. At least 3 meter. This is for make sure the drone will be work proper and efficiently, and then the drone will be fly with safe. After that, we need to set up the drone with remote control and phone and suitable application or suitable app like Fit for the Capture. Okay, actually Fit for the Capture app to draw the flight lane like this figure here. So this is the flight lane. So from the flight lane, the drone will be fly with automatically, will fly and landing with automatically. So from here we can get the image, okay, for the study area. So that image need to analysis to get the quality of orthophoto to do the road inspection by using orthophoto image. So this is for the Fit4D Mapper software, actually to combine all image from the UAV to get the data like orthophoto image and then digital surface model, what we call it DSM, and also digital twin model or DTM. So from here we can we get the result, and then the result will be transferred to the global mapper. Okay, actually global mapper we use to identify or inspect the road by using orthophoto. Okay, we can zoom up, zoom in to identify the road distress, like this figure. So this is patching road distress. So we can mark and we can measure the area of patching, and also we can measure the length of longitudinal cracking, okay, by using this software. And also we can measure the depth of the road distress. Okay, okay, so the global mapper software actually one of the GIS system. So query process in global mapper. So also we can query the information from this software, what we call it global mapper. So let's say we want to searching the longitudinal cracking. Okay, after we mark after the process mark the or identify the root distress, we can searching back. We can searching back the root distress. So for example, from this figure, this is the information from searching. We can get the length, we can get the area. And also we can know the location of each road distress, right? So pavement condition index. Okay, in order to get the pavement condition index, so we need to know the number of distress. We need to know the number of distress. So this is number of distress at Jalan Rengit 1. So we found it's about 8 type of road distress. So what we call alligator cracking, block cracking, edge, longitudinal patching, pothole, raveling, and traverse. So the highest number of distress is longitudinal cracking is about 23. Okay, this is because of the poor design joint asphalt layer shrinkage, crack reflecting up from an underlying layer, and longitudinal segregation due to incorrect paver operation. And then the second highest number of distress is block cracking. What is block cracking? Block cracking is a sequence of enormous, usually one fixed or more rectangle crack. So that's why we call this is a block stress and block cracking. And then the lowest number of root distress is patching and pothole. So this is for the Jalan Rengit 2. So we found it's about 10 type of root distress. So like this here. Okay, so if you can see here, the highest number of distress is also longitudinal cracking. It's about 19. So the second highest is about alligator cracking. Alligator cracking. This is because of the load-related deterioration resulting from a weak base course or subgrade, too little pavement thickness or overloading. Okay, this is cause of the alligator crack will be occur. And then patching, for the patching will be occur because of the poor of compaction, okay, and then poor of material selection, and the quality of the surrounding or underlying pavement cause the patching, okay. And then the lowest is blending, age, and pothole. Alright, so rating of pavement condition index or PCI. This is PCI value for Jalan Ringit 1. So actually for the Jalan Ringit 1 we divide with 5 section. So which is the highest value of PCI at the section 4 is about 84. And then the lowest value of PCI at the section 3 is about 58. Okay, the average of PCI value for Jalan Ringit 1 is 70. So we can classify for Jalan Ringit 1 is level of service B. So this means this road need preventive maintenance, okay, in order to maintain the condition of that road, especially focus for the waterproofing. Because to prevent the water from entering the pavement structure from above through a crack and joint, porous pavement surface material and unsealed solder. And then for the Jalan Ringit 2, the highest value of PCI at the section 1 is about 75, and the lowest value of PCI value at the section 3 is about 53, and for the average of PCI value is about 55. So we can categorize this Jalan Ringit 2 is LOSD, level of space D. So this means this road need a major rehabilitation maintenance as a maintenance activity, especially to repairing the damaged concrete pavements, damaged curb and surfacing. Alright, for the conclusions, the Jalan Ringit 1 had a pavement condition index rating of approximately 70, which is considered to the good. Okay, while for the Jalan Ringit 2 had a rating around 55, which is considered to be poor. Along Jalan Ringit 2, significant rehabilitation or postponed action has to be complete as a part of the maintenance activity. And then longitudinal cracking had the maximum number of distress indications, approximately 42 for both of road, while for the pothole and patching had the lowest number of indication is about 1 for both of road. And then the last is the use of UAV method for the collection of data was one of the way to reduce the risk of accident occurring. This was due to application of UAV will reduce the cost and time for the data collection. This is for the reference, and that's all. Thank you.